Hello, I'm Dean Martin with Transmission Digest. Welcome to the TranStar Industry Studios here at Babcock's Media.
Today we're going to discuss the General Motors 8L45 and 90 rear-wheel drive 8-speed automatic. Here with me again is Anthony Tosi.
Hello again.
Of Trans-Colonial Auto. Anthony did such a great job on the ZF last time. We figured we'll
do another 8-speed.
We'll do another 8-speed today. I want to thank the people at TransTech for the loan of their transmission and information in order to do this video. Before we get started, I want to issue a public service announcement. When a shop gets a car in to do work, it's with the intent they do normal diagnostics, determine what the problem is, sell the job, do the repair, send the customer on its way. Sometimes that doesn't occur due to inherent design problems, and it makes it a little tougher to do that work and make sure it's right. Such is the case of the 8L45 and 90. This transmission was released in 2015, and almost immediately they started having issues that have been a little tough to address. Typical things like torque converter shutter, also shift issues up and down, as well as delay engagement problems. To the extent that a class action suit was brought against General Motors last year, I don't know what the current status is, but the point being, when you get one of these transmissions in, make sure you do in-depth diagnostics, check all relevant TSBs, and inform the customer as to the issue. In the event that you have a problem, you don't want to end up in a running gun battle over it. So that aside, before we start peeling it down, I want to do a little overview. Again, these transmissions, although they operate similar to a ZF 8HP, this is definitely a General Motors transmission. As far as the case goes, it's a single case. If this was an SUV, of course, it would have a normal V-bell. This happens to be a Corvette. And of course, a Corvette bolts to a torque tube. That's why there's no bell housing here. Also, output shaft. You can have a two-wheel drive or four-wheel drive, or in the case of a Corvette, you have a much longer output because of the differential. This is a fairly open case, which means a lot of the components can come out through the front, a lot of the components can come out through the back. On this side, they don't have a dipstick as normal, and you pull this little rubber plug out, and that's where you can pump your fluid in. Also, this is where your label is, where your ton number, your transmission unique part number is, as well as a fairly sizable electrical connector. This thing's a monster. It's a 20 pin, but it's fairly sizable in diameter. On this side, you merely just have the manual lever as well as the cooler in and out. This transmission does not have, it is not a Tecum. It does not have the TCM internal. Finally, General Motors decided to have the TCM outside of the transmission, which is a plus. This unit has 5 clutch packs. There are 3 rotating clutches, 2 stationary brakes. All the rotating clutches are in front of the planetary gear sets for efficiency purposes. This has 4 planetary gear sets. They're all nested together in a compact set. As far as the valve body, there are 9 solenoids, unless it has start-stop, in which case it would have 10, to operate the transmission. So there are a fair amount of components in here, and when we start talking about the clutches, instead of the normal 2, 4, 6, 8, 1, 2, 3, we're going to refer to these clutch packs as C1, C2, C3, and so on. You'll see a chart on the screen that's going to list the actual clutch name as well as the C1, 2, and 3, so you know what we reference to. And of course, they're not in order. It's C3, C5, C4, C1, C2. Can you think of any other thing that needs to be covered?
No, I think we're ready to move on to the inside.
One thing I did want to mention about programming. All newer transmissions have to go through programming routine. It's even more so with the 8L series. GM uses their SPS, which is Service Programming System, and one of the programming modes is solenoid characterization, and that's where if you replace a solenoid or a valve body, this information has to be uploaded through the GM TIS2 web system so it can be downloaded into the TCM. There is also a service fast learn that has to be done as well after that. And finally, you get into the shift adapt. Each clutch pack has a shift adapt process. It's somewhat involved. You need to know how to do it. It takes a lot of driving and so on. So to make sure that this operates correctly, follow all the programming routines so that you don't have an issue after the work is done. So other than that, I guess we're ready to peel the unit down. Okay, Anthony?
Sure.
While Anthony's taking the pan down, I wanted to mention there is a certain process that you have to go through when you're doing clutch adjustments. Instead of just a normal put the clutch pack together, take a feeler gauge and check to see what your clearance is, General Motors has a fairly elaborate means of doing clutch pack adjustment. They actually want you to put a certain amount of pressure onto the clutch pack, which collapses the wave springs and mushes the clutches together. Then apply air to it to see how much travel you have. It requires a fairly expensive fixture, and you could do it that way, or you can take an aftermarket approach, which is basically just checking your clearance, deduct the amount of the thickness of the wave plate, and you're probably going to be close enough. One word on the pan. This, of course, has a motor rubber gasket, and there are two ways to fill this transmission: through the oil plug that I showed you on the case, as well as in this plug here, which is like a standpipe setup. You can pump fluid in here. To check fluid, you pull the plug out, see if it runs out, and you know if you have the fluid. Of course, it has to be at the proper temperature and so on. Okay, go ahead and yank the filter. Filter's not a big deal. What Anthony's going to remove right now is the off-axis pump cover, because to be able to get the stator support out, the pump drive gear has to come off, and you can't pull the valve body or the guts out of the case without doing this first.
And I'd like to mention, when you pull the gear, when you pull the tab for the gear to pull it off, it could go on either way, but only one way is right. The tab is going to face the inside. Now, if you were to turn it around, it probably wouldn't lock all the way. You just release this tab, pull up, and release it from the pump that's attached to the valve body.
Go ahead and hand me that, the drive gear. This lock, again, as Anthony mentioned, has to face inward to the pump, and it has to slide up so it disconnects from the pump shaft. If you put it around this way, it'll also fall off. So make sure that this is in the right way. This valve body is, again, fairly elaborate, and we can go ahead and take that off now. There's a lot of harness on here, as you might imagine. If this has a start-stop, you're going to have a similar setup on the like you do on the ZF8HP, to where you have an accumulator unit back here with a separate solenoid, and they started that in 2016. This has a normal lock here. It's kind of a different type of lock, but you have to pull up on this, and there are prongs in here that you have to squeeze together to pull the harness out of the valve body. On the solenoids, there are several different styles of solenoids, and they actually color code the terminals to make sure that you don't get them mixed up. It's not that easy to do, but the plugs are cut a certain way to avoid intermixing, and it certainly helps. It also has a TFT in it, and you'll notice on this transmission there are certain bolts that are not reusable. They're torque to yield bolts, for instance on this chain cover, and
I believe the speed sensors for some reason are torque to yield.
and the speed sensors are also torque to yield. Okay.
Let's mention real quick, inside of the pump, which we don't have split, is a gasket that GM, it's a metal gasket, but GM says not reusable.
Right. There is a fairly, as I mentioned, a fairly sizable electrical connector, and this plugs into the RPM sensors. And as you can see, it's a pretty good diameter, has a normal O-ring, and this hooks into the sensor. This plugs into the main harness. And may as well go ahead and pull the sensor wires.
Yeah, we have a few locating tabs here you'll want to lock down so you don't pinch wires, putting the valve body back on.
Yeah, it would be fairly easy to have those out of position and get them pinched between the valve body. Okay, again, this valve body, as I mentioned, has 9 different solenoids on it. There are 4 different styles, whether it's normally open, normally closed, meaning normally high, normally low. There are 2 on-offs, and you can tell there are actually part numbers to distinguish one style from the other, but also the electrical connector is cut so that each style has to be plugged to a particular harness terminal. So they did a pretty good job separating these. These also have the PUN unique part numbers in here that would have to be sent in to be able to upload to the TCM. This valve body is also the pump housing, and it's a fairly compact system. When you have these off-access pumps, this happens to be a dual chamber assembly, and this is the gasket that Anthony was talking about. And it not only has a gasket, but it also has this seal that sandwiches between the housing. And in here it's a normal vane type, as other transmissions have had for some time. One thing I do want to mention, this has a sleeve that goes in here. You can only put it in one way, but this needs to be in here to limit cavitation. So make sure that this gets put in so that you don't have air pockets getting into the fluid. Each one of these regulating type of solenoids has a regulating valve underneath of it. When you take these solenoids out, make sure each regulating valve gets installed back into the proper bore. What General Motors did, believe it or not, is they coded the bore. So they have A, B, C, D, E. It's marked right into the valve body, all the way up to G, H, and J. So it's a pretty good setup. The rest of the valve body has a couple of bonded plates, normal amount of check valves, has an accumulator for the C clutch, and other than that, it's not really a big problem to deal with. This also has an internal mode switch, like most newer transmissions, as well as it has one case seal which goes underneath the valve body. It must be there, and it's what seals the C1 clutch housing.
Now would be a good time to talk about the O-ring we left out.
Yeah. As you can see, Anthony pulled this out pretty easy. If this had the normal seal, which I don't think anybody has ever seen a larger, fatter seal than this, this provides a fair amount of compression, and there were actually two different designs of this cover. The earlier model had actually 3 threaded holes where you could put a slide hammer to hammer the cover off of the case. The newer model, they reduced that to 2, and they actually have a removal tool that clamps over and presses down on the input shaft to pull this off. Point being, it takes a fair amount of effort to get this, so you're going to have to use some type of slide hammer setup to work. Okay. And again, this is your drive gear. It could go in either way. You should probably mark it if you're going to put it back in, so at least it goes in the way it came out. It just has a small cover to stator support gasket. As Anthony's taking this off, I did want to mention a previous video was done to where I had mentioned about a delayed engagement problem, and that has to do with the torque converter drain back, and General Motors had redesigned this slightly, and not only the stator support, but also the cover itself. To give you a sense of size difference, again, this is an 8L90. This stator support happens to be an 8L45. So you can see the difference in size. It's a dimension difference. It has a sealing ring for the converter here. There's a washer that goes on either side of the pump gear. And on the back side, just has a couple of sealing rings for the clutch assembly. All right, with the stator support out of the way, we can now start pulling out the clutch assemblies.
Starting with the C3.
This clutch has a removable input shaft. It's got 7 sealing rings on it, and this actually drives either through the clutch assembly or the shell due to the spline in the drum. You want to pop this out. This is the only clutch pack that does not have a wave spring. And again, this is applied in 1, 3, 5, 6, and 7 gears, but it's why we call it a C3. And go ahead, if you want, pull out the next drum.
C4 now, and C5.
Right.
Let's mention that we have blind splines in this drum here. The snap ring should only go on one way.
Yeah, it's like on a 6L80. You definitely want to put the snap ring in the right way and make sure that the gap is on either side of the master spline. The first clutch pack to come out, this is actually the C4. It has a wave plate and it has master splines on the steels and backing plate to put it in the right way. It has an apply ring. Below that is the C5 clutch. The C5 also has a wave spring, and they have to be put in the right way.
And it also has a master spline.
Right. When we come back for part 2, we're going to go ahead and strip these drums and finish disassembling the transmission. I'm Mike Riley. Thanks for watching.